Hello, we're going to be trying the Senior Kangaroo, which is like the follow-on round for the Senior Maths Challenge. Yeah, from the Senior Maths Challenge. Am I speaking to the right mic? Yeah. We're going to see how it goes. I think it's going to be pretty hard. The way it works is every answer has to be an integer from 000 to 999. No idea how it's going to go. Haven't really done many before, so I'm just going to see what happens. So I'll put a timer on as well. Let's move stuff out of the way. Put a timer on the way. You only get an hour, which is nice. So let's do 60 minutes. And let's go. Okay. Not really done one before, so I don't actually know how it's going to go. Okay. The product has remainder r when divided by 100. What is 200 minus r? What? Instant no idea. So this is 10 times 21 times 120. No. 143. When it's divided by 100. Okay, so when this is divided by 10. Now, that's going to be 3, right? So is this 197? I mean, I could work out. You know what? Oh, I forgot about the 7. Oh, no, I'm just going to work out. Just to see if 41068 30101. Yeah. Okay. Next, the pie chart shows. The pie chart shows there are 2,000 students. The percentages are exact without any rounding. Approximately twice as many bicycles as use a bus. The rest train by train. Okay, what? Oh, exact without any rounding. Okay, so 47% is times by 2. That's 940. Then 11%. That's times by 20. So that's 22. That's 220. Then 6% is 120. And then 12% is 240. And 24% is 480. Okay, now what? Approximately twice as many use bikes. When you use a bike as use the bus. Approximately twice as many people use a bicycle. This could be bicycle. This could be bus, because it's approximately roughly the same number come by car as walk. So that, oh wait, that's car and walk. Okay, this is car and walk. This is bicycle, bus. So that means 6%. They're the people left. Let's use the train. Okay, that was kind of easy. Oh wait, what? 120. Okay, that's fine. The sum of 5-digit numbers equals this. The letters represent digits, which are not necessarily distinct. Okay, so we've got 100A plus 10B plus C plus 100B plus 10B plus 10C plus D plus 100C plus 10D plus E plus 100D plus 10E plus A plus 100E plus 10A plus B. Okay, and all of this equals 2,664. So that is 500. Oh wait, it's 555 A plus B plus C plus D plus E equals 2664. Wait. What? 1, 2, 3. A, B, C, D, E. B, C, D, E, A. C, D, E, A, B. 550 and 5. One sec. 2, 6, 6, 4. Does that divide by 11? It doesn't divide by 5. But it doesn't matter. Because if I divide it by... Okay, let's see what happens. 0, 2 remainder 4, 4 remainder 2, 2 remainder 2. No, I'm doing something wrong. The sum is 2664. So this number plus this number plus this number plus this number plus this number. Does that equal this? Am I losing my mind? Let's do an easier one. Let's say I've got AB plus BC equals like 30. So that's 10A plus B and 10B plus A. Wait, if this is like 19 and 91 is 120, then can I say 10A? I'm checking my method works. I'm not actually sure if it does. So that's 11A plus 11B equals 120. No. Wait, oh, wow, I've forgotten how to do this. Because I just need to divide... Wait, maybe we're fine? Because I just need to get to 10, so I need to divide this by... Okay, I need to do 2, 6... 555 divided by 10 is 55.5. Can I do 2664 divided by 55.5? So that's 5328 divided by 110, no, 111, which is, oh my god, what on earth am I doing? Okay, 5328, so that's 1 remainder 2, that's 7 remainder 2, that's 7 remainder 1, that's 6, 1776, 1776 over, what's this divided by 3? It's 37. 37 seems prime, but what am I doing? Okay, 0, 0, 111, 148, so that's 4 remainder. To get to that is another 28. Does it go into 286? What am I doing? Okay, so I need to add 37, so that's 185. That's 30, 215, 222. No, this is wrong. 259. Oh, wait, have I made 1, 2, 3, 4, 5, 6. You know what? Let's say that's 7. You know what? Let's say this is 47. No. Of course it's not. What am I talking about? Is this 47? But then I need to do this. I need to divide 400. Okay, no idea. Lost my mind. It's not divisible by 7. What's the smaller three-digit number, which is a counterexample to Kitty's claim? What? What is this? What on earth is this? Literally, what on earth is this? So, that is 30n squared minus 5n plus 6n plus n minus 1 times n cubed minus 2. Now what is happening here? This for the product is not divisible by 7. How the heck are you meant to know that? It's not going well. We're going on to question 5. We're hoping that we're going to find some things we actually like, some maths that we actually like to do. The integers such that ABC is 2 to the 16. Okay, all times together to make 2 to the 16. So 2 to the 16, and there are 3 things times together. The largest possible value. So we could have 2 to the 16, no, 2 to the 14, no, 2 to the 13 times 2 to the 2 times 2 to the 1. Could have that. The largest possible value of this, if this was 2 to the 7, 2 to the 6, we want this to be 2 to the 1. So we need this to be 15, so that could be 8 and 7. That could work. So then that's 2 to the 8 times 2 to the 7 times 2 to the 1. And then b is as big as possible, because if this was 8 and this was 9, oh wait, this could equal to 1. This could be 2 to the 0, so that could be 8 and that could be 9. We could have 2 to the 9 times 2 to the 2 to the 7. How could this be 8? Oh wait, they can be equal. It can be 2 to the 8 times 2 to the 8 times 2 to the 0. So it can be 2 to the 8. They're not distinct. Okay, 2 to the 8. So 2 to the 4 is 16. So 2 to the 5, so we've got 32. 6 is 64. 128. 256. 256. Okay, this next one looks horrible. Let's see what we got. Okay. 3 fed after 3 red faces, 2 white faces, 1 blue face, 2 red face. All 3 dice will show the same colour. Okay, so that's red, red, red. Okay, so we're trying to find the probability of red, red, red plus blue, blue, blue plus white, white, white. Red, red, red is 3, 2, 1, so it's 3 over 6, 2, 2, 2, 2 over 6, 1 over 6. Blue, blue, blue is 1, 2, oh, it's going to be the same. It's 3 over 6 times 2 over 6 times 1 over 6. White, white, white. Oh, that one's different. It's 2 over 6 times 2 over 6 times 2 over 6. Okay, 6 times 6 times 6. Why do I have 1080 there? Why do I have 1080? Should be 216. Then times 5, that gets you 2080. Okay, cool. So 6 over 216 plus 6 over 216 plus 8 over 216 is 20 over 216 times 5 is 100. Okay, nice. We're moving. There was some struggle, but now we're doing better. Okay, next. This. Ooh, I can difference of 2 squares, all sorts here. Can't I? Okay, if I look at this guy, that is going to be this plus this. A squared minus b squared. A plus b, which is hold on a minute. Can't I shake this round? I've got a plus b minus c minus d. I can write that as a minus c plus b minus d. Yeah. What am I doing? Let's shake these guys around. Those two and those two. So these gives you a plus d. They plus each other, which gives me 4050. They cancel, and then minus each other gives me this, take away this, which is plus 40. Oh, they're times together. And then this one would give me 4050, and then times 50. That's all divided by 1,000. Okay, so if I get rid of this, and this, and this, and this, and this, and this, then really I've got 405 times 4 times 4050, and I've messed up. Oh, because they're not all times together. I'm being a dingus. They're added. They're added. Yeah, they're added together. So if I divide by this, now let's change the colour. Okay, this, and then this, and this, and this, and then this, and this. And now I've got 405 times 4 plus 405 times 5 all over 10. I can factorise out the 405, so that's 405 times 9 over 10. And what's the value round up to the next integer? Oh, well, I don't know. I actually need to work that out. So 405 times 9, 9 times 5 is 45, 9 times 0 is 0, that's 4, that's 36. 0.5365. Oh, that's funny. I bet they love that it's 365. The first 4 digits. The first 4 digits of 108 business. How many digits does the square of this number have? Oh. Hello, pen. Come back. Ugh. Nope. Nope. Pen. Nope. Why is it? No. Ah. Okay. The first 4 digits of 128. What is this? How many digits does the square of this number have? Okay. 1 digit times 1 digit. One digit times 1 digit either has 1 digit or 2 digits. 2 digits times 2 digits. So that the biggest it could be is 99 and 99. Oh no, so 100 and 100 is 1, 2, 3, 4, 5, is 4 digits. This is smaller than that, so it's going to be 3 digits. So if we imagine it's that times that, it's going to have 256 digits, but it's not the biggest thing it could be, so it's actually 255 digits. Not sure about this one. Not sure. Whoa. The sum of... How many questions are there? Oh my god, there's loads! Okay, 19 integers, which are not necessarily distinct arranged in a circle. What's that same value? 20225. Whoa. Wow. How on earth do you do that? Oh, they... Oh, okay, one sec. They can't all be positive. So we've got 2025. And then a minus 2025. And then a 2024. Not necessarily distinct. Maybe they all need to be the same. Maybe it's just 2025 divided by 9. By 19. Oh, there's 19 of them. That is not divided by 19. Is it? 0, 1, 1, 0. Oh no, some of the gyms are only 9% proficient. Oh, okay, wait a minute. 0, 2, 2, 2, 4, 5. 250. They're all 225. Yeah, I don't think there's any other way of doing it, so I'm just going to do that. And also, this does work. They're all 225, so any 9, yeah, that's jokes. What's the area of the largest square? Oh, this looks fun. Area of the... Oh, yeah, yeah. Oh, I've seen puzzles like this before. 381. 3. Oh, no. Let's go small, please. 3, 9. So that's 3, and that's 6, and that's 9. And these are similar, so that's 18. So then, I mean, we could just find those. Guess. Well, that's going to be, whatever that is, that's going to be 3 times it. So really, what I've got is 4x squared. Oh, but this whole thing is 4. So this length is 4x. Can I do that? No, let's just use Pythagoras. Oh, I've got a screw fix thing here. Hello. How long have you been here? How interesting. Trying to buy a little plug socket, and now it's shown up. Maybe I could paste by mistake. Okay. So 3 squared plus 6 squared is 9 plus 36 is 45. A lot of 45s here. So this is root 45. This is 3 root 45. Altogether we've got 4 root 45. Now we're going to square that. So that's 16 times 45, which is also 9 times 5 times 2 times 8, which is 720. 10 times 78. 10 times 78. No, 72. 720. Nice. So I've got 19, and then I've got 11, and then I add those together. So K3 is K1 plus K2 plus K3. So that's 30, and then 41, and then 71, and then... Wait, if we just look at the last digits, it's going to be 9, 1, 0, 1, 1, 2, 3, 5, 8. Oh wait, and now we're just back to Fibonacci. 3, 5, 8, 5, 8, 3, 1, 4, 5, 9, 4. Wait, there's no pattern. Yeah, I'm not getting a pattern here. Hold on a minute. 7, 0, 7, 0. No. D plus 7 is 0, 0 plus 7 is 7, 0 plus 7 is 7, 7 plus 7 is 4. And then I'm back to 1. There's no pattern here. Now I've got a 6 showing up. Odd, odd, even, 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 odd, odd, even. I've got a pattern. It's 1 every 3. It's 1 in every 3. So, and 225 is divisible by 3. So I can just do 2025 divided by 3. Which is 0. That's a 2. That's a 6. That's a 2. That's a 7. That's a 1. 675. I'm going to say it's probably maybe like one more or one less, but let's see. Okay. You know what? The beginning was a disaster. We've sort of got into a rhythm. Oh, this looks awesome. This looks awesome. Just going to slam that in there. AM is 15. And MB, what? It's 12. Slam that in there. Don't know why, but it's cool. Okay, one sec. There's a circle theorem here that's like a reversey circle theorem, which is, please let me do maths. Please. There's a circle theorem here in like reverse. This line here, oh my god. I need the pen to work. I need it. I was doing maths. Okay, we're pausing because I need to fix my pen. Think I fixed my pen. New battery. Let's go. Okay, there's a circle theorem in reverse here. This line here, because these 3 points, because that's 90 degrees, this has to be the diameter. I don't know if that's useful, but that's kind of cool. Like, I don't think that's what we're doing here, but that's just kind of cool. So that's this, like, what do we do with that? So what am I even trying to do? This is 12, this is 15, and this is 12. Okay. This already looks fun. There's something about the tangent thing. This is cyclic quadrilateral. Those lengths add to 180. They add to 180. If they're all on a circle, are things the same distance? Okay, maybe I'll ignore that diameter thing, even though I think it's kind of cool. Instead, I'll draw this and this. That's 12, that's 15. How can I use that? I mean, I can find this length. That doesn't really help me. That's 27. What's the area? Oh, it's a rectangle. Read the question. You don't know that's 27. This is 27. That's 15. That's x. That's x. I cannot see anything, which is a shame because this looks really cool. I feel like there's something in this being the diameter, but I don't know what really. Like, so what? Like, is this an area maze question? Then I'm not using the circle at all. I can't actually see a way to link the circle and the like, they're obviously similar. That's irrelevant. We share the same height, so this area is going to be 5 to 4, 1.25 this area. If this is A, this is 1.25A. But that doesn't give me enough information. missing something. Don't know. That's a shame. That looked cool, but I just don't know. Ooh. Okay. So C is less than 0. And okay, so this has to be the derivative. It's going to have a positive root and a negative root. So like, it's not this, but let's just say it was this. So that'd be x squared plus x minus 6. This one how does this affect anything? One positive root, one negative root. A has to be positive. Oh wait, A is bigger than 0. C is less than 0. So this is negative. This is negative. This is positive. Now B, can I make something like if this is minus 3 and 2, then this would be negative. So I don't know if this is positive or negative. How do I know? It's going to be where the turning point is. The turning point is on the right hand side. So I think it looks like this, something like this. Something like this. So I think this has to be positive. I think B has to be positive, which means this is positive, BC is negative, B plus C it's signed to the turning point. Turning point, dy by dx equals 2ax plus b. The turning point, that's when 2ax plus b equals 0. So 2ax equals minus b, x equals minus b. Oh, I knew that. It's minus b over 2a. Now, a is positive. This is positive. X is bigger than 0. And a is bigger than 0. Which means b actually has to be negative. Huh. Because this has to be positive. A has to be net positive. But then if this is positive, this will all be negative. So B is actually negative. That's interesting. I did not know that. Okay, so this, but that also helps because then when I add them, it's obvious because they're both negative. So that's positive, that's negative, that's negative, that's negative, that's positive, that's negative, that's negative. When I times them all together, it's positive. So 3 of them. Wow, that is a mad cool question that I easily could have got wrong, but that's really, 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 really interesting. If I'm right, which I could easily not be, but that is interesting. I need to think more about that. That's really cool. Okay, the length of one side of a rectangular park was increased by 20%. Okay, what on earth are you talking about? So x and x. No. The length of one side. Do we know which is which? Oh yeah, it looks like this is 1.2x. This is 1.5y, and this is x and y. Okay, so we're looking for, we know that 1.2x squared times 1.2x times 1.5y over 2, that's that area, minus xy over 2 equals 210. So 1.2x times 1.5y minus xy equals 420. We're trying to find xy. We're not actually trying to solve this. We're trying to find xy. So, well, I can factorize this out. So I've got 1.2 times 1.5 minus 1 lots of xy equals 420. Yeah, and I'm trying to find xy. Okay, cool. I can do this. 1.2 times 1.5 is 1.8, so times that, so that's 0.8 xy equals 420. So xy equals 420 divided by 0.8, which is 4,200 divided by 8, which is 2100 over 4, which is 1050 over 2, which is 525. I feel like that's not my first 525. I mean, I could all be wrong. All of these could be wrong. But I'm having a good time. And also, I feel like I'm doing less badly than I did at the beginning. At the beginning, I was like, what on earth is going on? Okay, next. The sentence have at least 2 distinct solutions. Also, at least 2. What's the value of something, something, something? Okay. So 6x plus 15y equals 2a. Uh, 3a minus 3b plus 12 equals a plus 4b minus 1. Oh, wait, we also have 2a minus 2b equals a plus b. So we've got a equals 3b. But we also have that 3a minus 3b plus 12 equals a plus 4b minus 1. So that's 2a minus 7b equals minus 13. But a is 3b, so that's 6b minus 7b equals minus 13. So b equals 1. So a equals 3. So 10a plus b is just 31. Well, that seems easy. But I must have got that wrong because that seems easy. Okay. Yeah, I've still got 20 minutes. Okay. 6 and 2 angles are convex. Not sure what that is. Measure degrees are a hexagon. So a plus, we've got 1, 2, 3, 4, 5, 6. 6a plus, and then 1, 2, 3, 4, 5, 6, 10, 15d equals, a hexagon has 1080 maybe? No, 180 times 4, 720. 720. I can divide that all by 3. So that's 2a plus 5d equals 2a plus 5d equals 720 divided by 3, which is so that's 240. And everything is a multiple of 10. All angles are multiples of 10. So that means A and D are multiples of 10. So this could be D could be 40 and A could be 20. So yeah, that works. So 7A plus 11D is 140 plus 440, which is 580. Is this right? Everything should be... Okay, not sure if I'm doing things right. I feel like every single question I've done could be wrong, and I just wouldn't really know. Okay. Like that, I just guessed that. But it worked, so it's probably fine. Okay, next. Oh, how did I got 10 minutes? Oh, yeah, okay. M equals K minus 4, 3, 8. M equals 1.6 K. So 1.6 K equals K minus 4, 3, 8. Why is that negative? How on earth have I got a negative? It's that way around. 1 mile is 1.6 kilometers. Miles to kilometers. 1 mile is 1.6. So to get from this to this, m times 1.6. Yeah, okay. Oh god. So m equals 1.6 m minus 438. So 438 equals 0.6 m. So m equals 438 over 0.6, which is 4380 over 6, which is, I mean, we can just do that. 0, that's 7 remainder 1, that's 730. What? Why is that all so easy? But I also didn't seem that bad. Okay. Oh, 2 students. So that is W times W minus 1 over 2. Because this is, let's say, 30 people times 29, but then choose 2 students in class B. So V sorry, so A times A minus 1 over 2 equals W. B times B minus 1 over 2 equals, oh no, wait, class A has 4 more students than class B. So that's A minus, B is A minus 4. Yeah, so we've got A minus 4 times A minus 5 over 2 equals to V, but also W equals 3V. So that means I've got A times A minus 1 over 2 equals 3 lots of A minus 4, A minus 5 over 2. Okay, I can get rid of the 2's, so I've got A squared minus A equals A squared, 3 lots of A squared minus 9A plus 20. So I've got 3A squared minus 27A plus 60 plus A minus A squared equals 0. So I've got 2A squared minus 26A plus 60 equals 0. So I've got A squared minus 13A plus 30 equals 0, because that's good, because that's 15 and 2. So that's A minus 15. No, it's not. It's 10 and 3. A minus 10 a minus 3. So a equals 10, because a can't be equal to 3. So a is 10. Great question. Great question. Oh my god, it is 10. Great question. Really enjoyable, great question, good maths, really fun. You know what? Felt bad about it. Now I feel like I'm doing pretty good. But of course, I've got 50 minutes. So an almost number is divided into integers with exactly 8 elements of that. Oh, exactly 8 elements. Oh, that's really cool. So, exactly 8. How many can we exactly 8? So if it's 9, then it's also 3 and 1. So if you're divisible by 9, then it's actually 9, 3 and 1. If you're divisible by 8, then it's actually 8, 4, 2 and 1. If it's divisible by 7, it's 7 and 1. If it's 6, it's 6, 3, 2, 1. If it's 5, it's 5, 1. If it's 4, it's 4, 2, 1. If it's 3, it's 3, 1. If it's 2, it's 2, 1. If it's 1, it's just 1. So exactly 8, it could be this. So it could be, no it couldn't because there's overlaps. That's fun. So if it was 8, so I'd have that, 1, 2, 3, 4, 5, 6, 7, 8. I'm looking for the biggest one. But then you could also times it by any other prime. We want to make it as big as possible. So if I go 9, 1, 2, 3, 4, 5, 6, 7, 8. Oh, if I do 9 times 8 times 7 times 6, if I do this, then actually I've actually got 9, 3, 1, 4, 2, and 7, and 6. 2, 3, 4, 5, 6, 1, 2, 3, oh, and 8. Yes. So if I do 9, 8, 7, 6, and then I see what that is 72 times 42 for 1408. Oh, it's too big. Oh, it's too big. Oh yeah. Wait. To get to 1,000. No. Yeah. It has to be below 30 times 30. Or like 33 times 33. That gives me 99099. That's too big. 31 times 31. So around 30s. So if I do 31, which is prime, and then if I'm looking for like Hmm. 31 times 32 is 992. So if I do 31 times 32, now how do I make this? So that is 8 times, that's was by 8 and 4 and 2 and 1. Oh, I need more. I need like a 3. This is very interesting. This is very interesting. So it's like a prime, a big prime, Wait. If it's with exactly 8 elements, that means it's either not including 7, 5, 3. No, it has to include 2. It has to include 3. It has to include 4. has to include 1. If it includes 2 or 3, it has to include 6. Which means it has to include 9. So, is it these? If it's divisible by 9, then it has to be divisible. Okay, if it's divisible by 9, then it has to be divisible by 3. I can only remove 1. If I remove 8, it's still got 4 and a 2 in it. No, because it's divisible by 4. If I remove a 9, that could work. I can't remove a 4. Because then I can't remove these ones. So they're definitely in it. But these ones, if I remove a 6, that can't work because I've got an even and an odd. So it can't be 6. If I remove the 9, is this definitely divisible by 9? No. If I remove an 8, is this definitely divisible by 8? Well, it's divisible by 4. So I'm doing 1 times 2 times 3 times 4 times 6. Definitely. I have to be doing that. So that is 36 times 4, which is 144. And then I still need... No, I don't need to do that. I don't. I could just do this. I could just do 12. So I've got a 12 already here. Because 12 is divisible by all those things. Now, if I times that by 5 and 7, then I only need to times it by 3, like 35 times 12. No, 35 times 36 is too big. 35 times 24 is fine. Maybe it's 35 times 24. No, because then it doesn't include a 7 or a 9. Oh no, I did include the 7. So it just doesn't include a 9. Maybe it's 35 times 24. Let's see if this even works. 0, 2, 4, 3 is 12, 14, 0, 2 times 5, 0, 1, 2 times 6. No, it's definitely not 840. We can definitely be bigger than that. So if I ignore the 7, don't know. I'm going 840, question mark, don't know. Ooh. Okay. Okay. Factors of 1, 2, 2, 1. That is 11. Zero, one, 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 one. So it's 1, 1, 1 times 11. 1, 1, 1 is 37 times 3 times 11. So 1 across, but 1 down. Ooh, they have to be the same. Interesting. So I could say 33 and 37. Has to be. So that has to be a 3. And this could be a 3 or a 7, and this could be a 3 or a 7. Now, 2 down is a cube. I don't think there are any cubes with a 7 in it. Because 5 cubed, 1, 2, 5, 6 cubed, 2, 1, 6, 7 cubed is 3, 4, 3. 10 cubed is too big. 9 cubed, oh wait, maybe 9 cubed. 81 times 9, 9, 8, 729. Oh, it could be 729. 9 cubed. So it could be 343 or 729. Can this, so this this is either a 4 or a 2, and this is either a 3 or a 9. Now, 5 across is a prime. The primes, that could be 31 or 37. They're the two primes in the 30s. So this could be a 1 or 7. And then this down was 3 across, multiple of 17. God, I don't know, multiple of 17. 17, 34, which means 340. That could work, but that can't be a 0, so it can't be that. So 357, 323, 306. That has to be a 4 or a 2. So it can't be that. It could be this. And that. No, because if it's 343, can't be 340. Could be 323, could be 357. No, it can't be 35. We're doing what we're doing. We're doing 3 across. Can't be 357. It could be 323. Can't be any other ones. So it could be 323. Could be 323. But also, it could be something in the 7s. So, let's times this by 50. So 17 times 60. 0, 0, 2, 4, 6, 1. 6, 1 plus 6 times 1 is 6. Whoa, wait, that's way too big. Wait, what? Well, I just mean multiples of 17 in the 700s. So that's 34, 680, add 17, 697, 697, add 17 is 714, 731. Oh, there's no 2 there, but there is a 748. Okay. So it could be 748. It could be 748, or it could be 323. So this, 4 down, is 87 prime? No. And 81's not prime? No. But these both can't be 3s. If it was 323, then it's 729. And then it could be 91. So it could be this. Could be this. $91 prime? I think it is. Is it in the 17 times table? No. Okay, so what's 1 across, 3 across, 5 across? 37 plus 323 plus 91. That's 11, that's 15, 451. 451. Okay, I'm basically out of time. That was fun. I could not do this. I couldn't do this, which is sad. That looks really cool. Let's use a different color pen. So couldn't do 12. Couldn't do 19. Also could have messed everything else up, but I didn't know how to do. Couldn't do 3 or 4. In a way that I'm like, what? I mean, I've got a minute left. Claims that for every positive, the product is not divisible by 7. I'm literally no idea. Like, if n is like a 3-digit value of n, like I just have no idea how to do this efficiently. It just doesn't seem nice. This is annoying though, because here I had 5, 5, 5 lots of A plus, B plus, C plus, D plus E. But I think, have I lost my mind in saying this equals to 2664? Or is it... But then I couldn't divide by it when I divided by 55.5. I couldn't divide this by 55.5. Like 470 or something. I don't know. Okay. Well, at a time. Very enjoyable. Very fun. Don't think I did great. But you know what? Saying that, there were 4 questions that I couldn't do, and then, which I think I could, so I might take some time off cam. But aside from that, very enjoyable. Easily could have made loads of mistakes. Probably did. Had actually a very good time. Super enjoyable. Thank you so much for watching, and I will see you in the next one.